Assalamu alaikum and very good morning dear students. Today is the third and last video lesson of this chapter, and the chapter is Introduction to Sets. Today's topics are types of sets, cardinality of a set, and symbols used in sets. Dear students, please open your mathematics books, new countdown, book 6. By the end of this lesson, you should be able to identify and use types of sets, understand and calculate cardinality of a set, and identify and use the symbols of sets. There are so many types of sets. Some are very interesting. Number one is finite set. As the word is telling finite, it means it is limited. And the example of a finite set is set of days of week. Obviously, days of week are limited. These are 7. It can't be 8, not even 6. Now, the second is infinite set. Yes. Who knows about it? Yes, obviously, the word is telling it has unlimited elements in it. For example, set of stars in the sky. It has unlimited elements, so it is called infinite set. Now, the next is unit set or singleton set. Again, the word is telling unit, it means it has just one element in it. For example, set of first letter of English alphabet. Obviously, first letter is one and only A. So it is unit set. And then empty set or null set. This set has no elements in it, like empty set, so no element. For example, set of 2-digit numbers greater than 99. Yes, all of you are smiling. Yes, it's funny because greater than 99, that is 100, and it has 3 digits. So there's no number which is more than 99 and has 2 digits. Now, the next is overlapping sets. Now, who can tell me overlapping set? Yes, the word is telling that the members are overlapped. It means there are some common members in it. So, for example, set F is A, C and F as its elements, and set G has C, E and G as its elements. So, what is common member here? C here and C here. So, this is overlapping. Both the sets are overlap each other. So, set F and set G are overlapping sets. Now, equivalent sets. Again, the word is telling it is not equal but have some similarity. For example, set R has members A, B and C, and set S has F, H and J. It has 3 members and this set also has 3 members. So, the members are different but the number of members or number of elements are same. So it means this is called equivalent sets. So set R and set S are equivalent sets. Now equal sets, as the word tells, these are exactly equal. For example, set C has elements A, B and C, and set D has element set of first 3 letters of English alphabets. Obviously, first 3 letters are A, B, C. It means it is written in different way, but elements are same. So these are equal sets. So set C is equal set of set D. Now, universal set. Universal set is a bigger set. I think it will be clear when I will give you one example. For example, set K has elements Tuesday and Thursday, and set L has elements Saturday and Sunday. And the universal set of set K and set L is days of the week, like a bigger set but related to both of these sets. So it is called universal set. I think you remember you learned this in Venn diagram. Now, disjoint sets. These sets are completely separated. There is no link, no resemblance, nothing. For example, set A has elements 1, 2 and 5, and set B has elements 3, 6 and 7. No matching. It has different elements, it has different elements. By chance they have same number of elements, but it doesn't matter, they are different. So set A and set B are disjoint sets. Now subsets. This type of set is important. You will learn about it later in detail. For example, set T has elements 1, 2, 3, 4, 5 and 6, and set V has elements 1, 3 and 5, and set W has elements 2, 4 and 6. If you will note that all these elements are elements of set T, and then all these elements are also elements of set T. So it means set V and set W are subsets of set T, and you can say that set T is superset of these sets. Okay, now set V is subset of set T and set W is also subset of set T, and we will write it by using symbols as set V, this is symbol of subset of set T, and set W is subset of set T. Now superset, as I just told you that the bigger set is superset over here, like for example set Y has elements A and O, and set Z has elements A, E, I, O, U. So this is bigger set which has all the elements of set Y. So we can say set Z is superset of set Y, and we can write set Z is, this is sign of superset of set Y. If you notice that this sign is opposite of subset. Yes. Now power set. Power set is a set which has all the subsets in it. For example, set E has members A, B and C, and all possible subsets of set E are elements of its power set. Like for ABC, the subsets are first of all empty set, then a set which has element A in it, then another set which has element B in it, then C as an element, and then another set which has A and B as elements, and one more which has A and C as elements, and one more which has B and C, and another set which has A, B and C, like all the elements which set E has. So all these are subsets of set E, and this is power set of set E. I hope all these things are clear, but to make it more clear and to reinforce your concept, I want to show you a video in which some of the points which we discuss will come under consideration.
We look at just two simple sets in this video. Set P, which has 1, 2 and 3 as its elements, and set Q, which has 1, 2, 3, 4 and 5 as its elements. Understand the elements well. This has 1, 2 and 3, and this one has 1, 2, 3, 4 and 5. This is a part of this, and that's why we say set P is a part of set Q. And we learnt in the previous video that part of also means subset. So we can say that set P is a subset of set Q. Do we have a symbol to represent this? Yes, it's written like this. P is a subset of Q. The letter U is sleeping on this line. So when is P a subset of Q? Set P is a subset of set Q when every element in P is also present in Q. Look at the elements. Every element in P is also present in Q. But this statement raises a new query. Look at sets C and D. Set C has 4, 5 and 6 as its elements, and set D has 4, 6 and 5 as its elements. Both the sets have the same elements, which makes them equal. But every element in set C is also present in set D. Based on the definition, we can say that set C is a subset of set D. This also tells us something more. It tells us that every set is a subset of itself. P is a subset of P, Q is a subset of Q, and so on. For some reason, this does not seem entirely correct, and that gave rise to a new concept of proper subset. Look at sets P and Q. Set P is a part of set Q, but there is at least one element in set Q which is not present in set P. We say that set P is a proper subset of set Q. This sign indicates proper subset, and this tells us that all elements of P are present in set Q, but there is at least one element in Q which is not present in P. We can see that 4 and 5 are not present in P. So that's the concept of a proper subset. Sometimes it is also referred to as the strict subset. Can we say C is a proper subset of D? Think about it. That would be incorrect since there is no element in D which is not a part of C. There has to be at least one such element. That's the only difference between a subset and a proper subset. Just one last thing we need to understand. Just as we say P is a proper subset of Q, we can also say that set Q is a superset of set P. This symbol is used to represent superset.
I hope your concept of subset is stronger now. Now, cardinality of set. Cardinality is actually when we find cardinal numbers, and the number of elements of a set is called its cardinal number. Like for example, set A has 2, 5, 7 and 11 as its elements. If we count these numbers, these are 1, 2, 3 and 4. So the cardinal number of set A is 4. Now set B has elements A, E, I, O and U. Now count these: A1, E2, this is third, this is fourth and this is fifth. So the cardinal number of set B is 5. So I think this is very easy concept, that we just count number of elements of a set and it is called its cardinality or cardinal number. Now the symbols which we use in sets, there are so many symbols and all of these are given on page 13 of your textbook. But for make it easier for you, I have written all these over here. Now this symbol is very common. We are using it since I think years, and this we can use it in sets also, and the symbol is for equal sets, and this is for unequal sets, and this is for equivalent sets, this is for not equivalent sets. And this symbol which we learned in our first video is member of. This is sign of member of, and this is when it is not member of. This sign is for empty set, and this is subset, and this is not a subset, and this is a proper subset, and this is not a proper subset. And the last is for such that. Where do we use this sign? Yes, in set builder notation. Very good. Now, the summary of today's lesson. What we learned today? Types of sets. There were so many types. Some were very interesting and some were very important. And then cardinality of a set and symbols used in sets. Now with the help of this learning, I think you can easily